The best way to get better at programming is to practice. In this example, we're going to look for where do we find people that are in both sets of data. Likewise, we're going to be looking for people who are only in one set of data. As always, you can download this file from the link provided in the description below and then follow along with us. Or you can attempt it on your own and then check your answer. Alright, so the first thing I want to do is find people that are in both sets. This is known as an intersection. So I'm just going to print this out and say set1 dot intersection set2. And when I go and run this, I'm going to see that both Lori and John are in both my sets. So the intersection is a great way to find where I have two or more sets that have overlapping members. Now, if I want to find all members, regardless of if they overlap or not, that's a union command. And it's very similar. In fact, I'm just going to copy and paste this. And instead of intersection, I'm going to say union. And now you can see I have all my members with no overlaps. Now, what happens if I want to find people that are only in one of the sets but not both? Well, that's an interesting question. So I'm going to come up here and say print set1 dot, and I'm going to do symmetric difference. And what am I going to pass in? Well, I'm going to pass in set2. When I run this time, you'll notice that my first time I see Lori and John. Those are people who are in both sets. Then I see everyone. So you're going to see Lori and John in that one. And then my third result, I don't see Lori and John. That's because they occurred in multiple sets, and we were only looking for elements that were in one set. And so that's the difference between symmetric difference, union, and intersection. If you like this example and seeing how sets work, please consider subscribing to see more examples.